So we are going to do 4.5. This is the last lesson for chapter 4. So if you have any questions, I will go over that first. Otherwise, we can do chapter 4, 4.5, and then done with the chapter 4. All right, so let's moving on to 4.5. This is the last lesson of chapter 4, integration by substitution. So it's a little bit more complicated than before. So we're not just doing a power rule. I mean, we're not just doing an anti-power rule, like using a power rule to take a derivative. And I call it anti-power rule because you're using just like a power rule, but the derivative, whatever you power of the function, you reduce one power, right? And then anti-derivative means because you reduce one power, so anti-derivative means you're gonna add one power. And then derivative, you multiply your coefficients. Your power become your coefficients and you multiply with your coefficients. But anti-derivative become your power become a denominator. Right now, so we're still going to integrations, but we're going to do use substitutions, okay? So we're going to we got to recognize patterns when you do the substitution problems, okay? We got to change in variable, okay? General power rule for integration is to find the indefinite integrals, and you should change a variable to evaluate definite integrals, evaluate the definite integral involving an even or odd functions. This one we can do later. Okay, pattern recognitions. Okay, we're gonna use it, and we call it use substitution. Okay, we're gonna substitute the patterns. Okay, then we're gonna do use substitution. So, for example, so we have this problem. So let's look at the real problem. So we have this problem. So when you have this problem right here, x squared plus 1 to the second power. So we're gonna rewrite this as u as a x squared plus 1, what they call it g, okay, it doesn't matter. And then we call it du to be 2x. So we can rewrite this problem as u squared du, because this is called pattern recognitions, okay? So you can see this is your u. So that's the same as uu, and over here, that's your du. All right, so that's why you have 2 power. So you put the u square and du. All right, then you know what to do, because u square now, okay, when you look at this problem, x squared plus 1 to the square 2x dx, you cannot just use a regular power rule because you got to have a derivative of inside of here, okay? So like this is different from like this kind of problem. When you have problems like that, you can take antiderivative of each individual one, right? You can do individual one. So we cannot do that. So what we're gonna do, we're gonna make this problem like problems we already know how to do, which means if I do substitution problem, we set that as u, okay? And this become a dx, I mean, the whole thing become a du, then this problem become a like a regular problem that we know how to do. So that's equal to u to the 3 divided by 3 plus c. Then we're done, right? But after that, after you do use substitutions, since your original problem is in terms of x, so you put it back what u is equal to, which is x squared plus 1 over 3 plus c. Then you're done. All right, let's look at another one. Okay, somebody have a question for me? Okay, so I'm gonna look at the, okay, this one is little more, I'm gonna look at the ones that doesn't take so much, let me see. I probably need to look at your homework problem to find this. Okay, so let's look at this problem. So there's a lot of substitution things that we can do. So I am going to write this down so I can use this problem as your example problem. So let me write this down. So first A is 3 times 3x minus 1 to the 4 dx. B is 2x plus 1 and x squared plus x to the dx. And C is 3x squared x to the 4 minus dx. All right, so let's look at this problem in a notebook. Okay. So doing a 4.5, use substitution. So the first problem, example problem 1, this is what they have. 3x minus 1 to the 4 dx. Okay, whenever you see a combination of two problems like this, especially 4 power like that, you do not want to multiply them out. If you're trying to multiply them out, it's too much work. So you need to think about yourself right away. Okay, I got to use substitutions. Okay, so the use substitution usually use whatever inside the parentheses is going to be your u usually. Like inside the parentheses or inside the radical, that is usually your u. All right, so we're going to call that to be u. So u is equal to 3x minus 1. Okay, derivative of u would be 3 dx. All right, so do you recognize the pattern? So now I can rewrite this problem as u to the 4 and du. Does everybody see it? The pattern is this and this together become a du, right? Over here. Okay, now once your problem become like regular problem, then you can simply do u to the 4 plus 1 divided by u to the 4 plus 1 plus c, or you can say u to the 5th divided by 5th plus c. But I'm not done yet, remember, because we did use substitution so we can take antiderivative easily. But the original problem is respect to x. So I'm gonna do exactly the same way. So I'm gonna put back my u. My u is what? U is this. So I'm gonna plug it in, which is 3x minus 1, everything over 5 plus c. So that is your answer. All right. So I want you to practice this, okay? You're gonna do this kind of problem. So on your exam, I will ask you to give you problems like this, okay? And then you need to tell me what is UU, what is DU, and you need to show me all this step, okay? If you don't show me this step, again, you know me how I grade your paper. If you skip your steps, if you don't show your steps, and you just get the right answer right here, I will only give you 1 point out of 10 points because I have no idea how you got your answers, okay? You need to show me your work. So make sure you show your work. So your exam will be like this. So second example. All right, so in this case, you do have a parenthesis over here. There's 2 different parentheses, you know it. Okay, you have a 1 over here, and you have a 1 over there. Okay, so as I said before, if you have a parenthesis, usually inside the parentheses, it become your u. But this case, since this one has a power, so I know for sure I will choose that one as my u. Okay, so again, my u equal to x squared plus x du, taking a derivative of this, which is 2x plus 1 everything to the dx. All right, so then now it's exactly what we want. So you can see it. That together makes du. All right, so now I have exactly what I want, u squared du. Right? So now that this problem becomes just like before. All right, now I gotta plug it in my u. That's my u. So I'm gonna plug back in, which is x squared plus x over 3 plus c. Then we're done. All right, are you following me, class? Because you need to understand how to do u substitution to do antiderivative. So I'm gonna show you another example. All right, class, I want you to tell me what is my u? What should I choose as my u? Which one? Which expression should I choose as my u? 3x squared or x squared minus 2? Ethan, which one should I choose?
X squared minus 2.
X squared minus 2? Yes, definitely. Because I told you, you choose whenever what? Inside the parentheses or inside the radicals to be my u. If it doesn't work, of course you can try different combinations. But the best thing to choose is inside the parentheses, inside the what? Radicals. That's the first choice. If it does not work, yes, we're gonna try something else. For now, let's try that. So x squared minus 2. So what's du? Marzi, are you here? What is my derivative of u?
2x.
2x dx, that's right, right? 2x dx, great, good job. So next, Bernice, what is my du? Do you see my du combination? Is this my du right there?
Ma'am.
Do you see my du combination right here? 3x?
Yes, ma'am.
Wait a minute, is it 3x squared? Did I write that wrong? Oh, sorry guys, this problem should be 3x, okay? So I got it wrong here. All right, so okay, this is a little more complicated. Everybody see it? Let me erase this part because it is not same. Okay, look at this, class. This is a little more tricky. What do I have here? I have 2x dx. But what this problem has, 3x dx, isn't it? So in this case, I want you to rewrite your problem like this. Watch me how I do. So bring out the 3 in the front and just leave x, just leave this, x squared minus 2 and dx and x, okay? Okay, so what did I do? I took it out. Watch me, you guys, watch carefully. I took out the 3 in the front of integrals because I don't want to worry about my 3. What I need is 2, okay? So I'm gonna multiply 2 to this problem. And then I will divide it by 2, like this. If I do 2 divided by 2, what's that equal to? 1, isn't it? So that's the concept we're using. So I'm gonna multiply this by 2. Since I multiply by 2, I have to divide it by 2. Are you following me? Watch carefully again. what I need is 2x dx, but I have 3x dx. So what I did is I bring out the 3 in the front, so I don't want to worry about 3. So I just make it as x dx. All right, this x right here, I put it down over there. So I make it to be x dx. And then I said, okay, what I need is 2. Since I have 2 over here, so I multiply by 2. That means I have to divide it by 2 also. All right, that's just like 2 divided by 2 is equal to 1. So I'm not changing my problem because 1 is identity of a multiplication. So anytime you multiply by 1, your problem does not change. So now we got exactly what we wanted. So we have 3 over 2 integral u to the 1/2 and du. So this problem is a little more complicated than before, but it's okay. We do exactly the same way we always do. So u to the 1/2 plus 1 divided by 1/2 plus 1 plus c. So that's equal to 3/2 u to the 3/2 divided by 3/2 and plus c. Okay, it happened to be the 3/2 and 3/2 cancel out. So you have a u to the 3/2 plus c. Then we got it now. You know what u is? U is square root of x squared minus 2. And then I'm going to multiply everything by 3 plus c. So we're done. So this is a little more complicated than other kind of problems. So I'm going to give you another problem like this, just to make sure that you can understand. All right, watch this one, or you can do screenshot, because I'm going to give you another problem like this so you can practice. All right, did you take a screenshot? All right, let me give you another problem, similar problem. Here's example 4. All right, so you have this problem. I want you to take antiderivative of this problem. How would you do it? The first thing first, you gotta choose which one to be your u. All right, any volunteers will tell me what my u equal to and why you choosing that as your u. Okay, any volunteers? What is my u should be?
The u is what's in parentheses.
That's right. That's the logical choice to choose. So u would be 2x squared plus 4. So inside the parentheses, that's what I chose to be u. All right. So far I have a u to the 3rd. Okay, now what is my du? So du is what? Karin, are you here? Okay, Shalia, are you here? What is my du?
4x.
4x dx, right? 4x dx, the 2 times 2 give me 4, 4x dx. So you're gonna compare again. Everybody watch. I am left with the 2x and dx. Or what I need is what? 4x. So I will do just like I did before. I put the 2 Okay, I will put the 2 in the front, right? And then I'm gonna put this x and dx together. Okay, and then you're gonna tell yourself, I need 4 Since I'm doing a 4, I will divide it by what? 4, because 4 divided by 4 is equal to 1. Remember that. Okay? So now this is du. So I can rewrite my problem, u to the third du, which is the same as 2 divided by 4 is the same as 1/2 u to the third du. That's equal to 1/2 u to the 3 plus 1 divided by 3 plus 1 plus c, which is same as 1/2 u to the 4 divided by 4 plus c, which is the same as 1/8. U is the same as 2x squared plus 4 to the 4 plus c. So you're done. All right. Are you following me how to do this kind of problem? So you need to make sure that you know how to do U substitution. Okay, so practice this on your homework problem. So I went over a few of them with you right now. All right, so let's go and finish our lesson 4. So we did it, so we're done. Okay, now it's an integration of even and odd functions. Oh, next thing. So if they gave you a number like this, let's practice this, okay? I'm gonna do this problem over there in a notebook. Say this is an indefinite integral. Indefinite integral means you don't have a limit. Okay, and then now let's look at the definite integral problem, example 5. Say you have this problem. Okay, you don't know how to do this kind of problem, regular antiderivative. So you do have to use U substitution again. So let's do the U substitution. So my U is equal to this, x squared plus 1. So I'm gonna do same thing. Okay, and then du is 2x dx. All right, so this case is just simple. I need a 2, but I don't have a 2. So I'm gonna just multiply by 2 and divide it by 2, because 2 divided by 2 is the same as 1, remember that. All right, now, then I have this. I have a u to the third and du, and I have 1/2 in the front. But now remember this, your limit over here is x equal to 1, your limit over here is x equal to 0. So you have to see what is u over 0, which is 0 squared plus 1, which is 1. U over 1 is the same as 1 squared plus 1, which is 2. So if you want, you can do this. U is equal to 1 to u equal to 2. All right, then you have 1/2 u to the 4 divided by 4, and evaluating u equal to 1 and u equal to 2. So you get 1/2 times 2 to the 8 over 4 minus 1 to the 4 minus 4, which give you 16, right? 16 over 4 minus 1/4, which give you 1/2, 15 over 4, which is the same as 15 over 8. So that you get. So changing in variable means that's what they're talking about. If you want, you can do that like this. Or let me show you another way. If you choose to, or 1/2, you can still living as x equal to 0 and x equal to 1 and u to the third and du, and you still get 1/2 u to the 4 divided by 4. Okay, in this case, you need to put it back your u as, what is your u? This. X squared plus 1 over 4. And now you are evaluating 0, x equal to 1. You get the same answer. 1 squared plus 1 over 4 minus 0 squared plus 1 over 4. Oh, excuse me. Everything to the what? 4. All right, so you get 1/2. 2 to the 4 over 4 minus 1 to the 4 over 4, which you get same answer. So either way, you get the same answer. So if you don't want to change your limit, this is a changing limit in terms of u. All right, so right now your problem comes with x equal to 1 and x equal to 0. But if you want to just use u as your variable, that means you need also change your limit in terms of u. If I plug it in, u at 0 and u at 1, that came from this number. All right, but you don't have to change if you want to change back into x. If you want to evaluate it in terms of u, then yes, you have to change your limit to u. But if you want to change back to x, then you don't have to change your limit because you can just simply plug it in, the x over here. So either way is fine. So you can do either way. Either way works. Just you need to know how to do u substitutions. All right, so this is what they're talking about, okay? So you get to choose whichever you want to. You can change your limit to u and evaluate it, or you can leave your limit as x and change back from u to x and then evaluate it. Either way, you get the same answer. Now, let's look at the integration of even and odd functions. Okay, this is an even function. Okay, even function means when you draw like a vertical line at origin, like y-axis right here, as you see this, your left-hand side and your right-hand side is exactly the same. That's called even function. Okay, now look at this function over here. This is odd function. The odd function means your left and right is exactly opposite y values. For example, right here, this one is negative a, and say this is equal to 1. Okay, now look at this one over here. That is a and then what? 1. They're exactly, oh, excuse me, negative 1. They're exactly opposite. Okay, when negative a is become a what? Positive a. Positive 1 become a what? Negative 1. So they are opposite sign. Your answer is exactly opposite. And the even function is the exactly same. For example, over here, look at this. Negative a, say this is 1. This is what? A and 1. So y value is exactly same. When y value is exactly same, when your x is become a negative x, that's even function. In other words, f of x is the same as f of negative x. That is even function. Okay, and odd function means f of x is the same as negative f of x. That is odd function. Okay, now look at this. Remember, your derivative means area. Okay, so look at this. Odd functions, you have a negative area right here. What do you have over here? Positive area. this and that, they're exactly same. So our function, when you take antiderivative, your area become a 0. The net is 0. Okay, so net area equal to 0. An even function is, you look at this, if you ever find the area of this, say I'll call it this is equal to area A. Okay, then look at this one, they're exactly same. So even function means you're gonna have a 2A, 2 of exactly same area. If I call it this to be A, you just need to multiply that by 2. That give you twice more than it used to be, because it's an even function, it's exactly same. So this is what they're talking about. If it's even function, that's the same as you just multiplying by 2, but this time you're evaluating from 0 to A. And look at the R function. If this is R function, you get a 0, because your negative area and your positive area is exactly same. Okay. So look at this problem. Okay, look at this graph. Can you tell me whether this is even or odd function? Is this an even function or odd function? India, look at the graph and tell me, is this even function or odd function?
It's odd.
Exactly, they're odd function because your negative power, negative area is exactly the same as what? Positive area. When I say positive area means you have x-axis, above x-axis is a positive area. Okay, below x-axis is what? Negative area. Since this area cancels out with that area, so this is negative area, and that's a positive area. When you add it together, you get a 0. So that is a odd function. So odd function, you don't have to do anything. You can just say this is an odd function, your area is equal to 0 because they will cancel out. So that's it for today's lesson. We're done.